think probably we're at the point where we can go ahead and formally take this live, and there will still be a lot of people tuning in later, so I'll reintroduce us a couple of times. But I want to say to all of you who are watching this, welcome to the weekly Science Hour. I'm Emily Lakdawalla, your host this week. I alternate with Pamela Gay. And this week I'm delighted to have as my guest Bill Nye, the planetary guy, for a fun hour of chatting about science and other fun stuff. We are both, all three of us actually, that you can see below it. The third face on your screen is Mat Kaplan, who is the host and producer of our weekly podcast, Planetary Radio. We all work at the Planetary Society. It is the world's largest space interest group. And what that means is that we advocate for more space research and exploration. We do public education. I write a blog. We have a podcast. And we try to get funky, cool new hardware on the surfaces of other planets. So those are just a few of the things we do, and Bill will have a lot more to say about that. You can also, if you would like to ask Bill any questions, or me, or Matt, you can post them as comments on Google+, or you can post them on Twitter using the hashtags #CQX, #Hangout. And we'll be watching for your questions there, and I'll try to feed as many of them as I can to Bill. So, Bill, why don't you go ahead and take it away and let us know what's on your mind?
Well, what's on our mind, everybody, is the NASA budget. Even if you don't live in the United States, you live somewhere else in the world, NASA, the National International Space Administration, spends more money than anybody else on space. So our concern is that the planetary budget, the budget for planetary science, has been slashed. And this is in nobody's best interest. That's our claim. That planetary science is where NASA has had its greatest successes of late. It's the crown jewel of space exploration at the world's largest space agency. So by cutting this budget, it's probably bad for everyone on Earth. And I'm not being extraordinary or exaggerating. There's only one organization so far that can routinely land spacecraft on other worlds. It is not trivial. You may have watched science fiction movies, but they don't even land. They just beam down. Well, in real life, we can't do that. So it's very difficult for people to land spacecraft on other worlds. For example, the Russian Space Agency, which is currently the premier way to get to low Earth orbit with the Russian Space Agency rocket. That organization is 0 for 21 sending missions to Mars. They tried 21 times and missed every time. It is Mars is hard, as the saying goes, very difficult business. So we want to maintain the world's expertise in going to other worlds. And I had nothing to do with this. I was born in the U.S., so I am a U.S. citizen, and I am, after a fashion, in favor of the U.S. And so having the U.S.'s space agency budget cut is, for planetary science, is not good. And the thing that everybody talks about, the thing that was being discussed at this hearing with the administrator of NASA, Charles Bolden. Well, this isn't actually Charles Bolden. This is a picture of Charles Bolden. Right? I know this is virtual. I just want you to be engaged. So he did what he could to reckon the U.S. Congress's directive to build a rocket, which is hilariously called the Space Launch System, that some people, in perhaps mean-spirited fashion, refer to as the Senate Launch System. NASA's been directed to build this rocket, and the money that that's taking is affecting the budget for everything else, especially in our opinion here at the Planetary Society. It's affecting the budget for planetary science. So this is what we're working on right now, Emily.
So, Bill, can you let me know why should we even care? Why is it important to land on other worlds? Don't we have problems here on Earth?
No, it's not important. No, I'm kidding. It's vitally important, people, because let me ask you a couple things. First of all, if you stop exploring, if you stop looking out and up, what does that say about you? whatever it is, it's not good. I'm going to stay home. I don't care. Okay, that's for one thing. Then the other thing is we are closer than any other human generation ever to finding life on another world. Now, I know many of you out there want to go or send missions to Europa and Enceladus and Titan, and I'm right there with you. Yes, yes, yes. I applied to be an astronaut several times. Of course, for me, it's something like, how many PhDs do you have? That's on the questionnaire. And the first one is A, 100 to 300, B, 100 to 1,000, 300 to 1,000, or C, more than, no, okay. The people who become astronauts now are just astonishingly qualified. That aside, Mars is the most logical place for us to look next. We've explored Mars, we found out where the water was, and we're pretty sure we'll be able to find out where the water is. And then we have now instruments going there that can look for signs of life, literally. Someday soon, we hope to sniff for methane. But the other thing, this spacecraft that's on its way right now, while we're sitting here talking, is going to be able to detect sterols, like cholesterol. And so if we found sterols on the planet Mars, it would mean almost certainly that Mars once had living things. These would probably be some sort of Martian microbe, a Marscrobe. And if we found that, it would change this world. Nobody would ever be able to think about his or her place in space in the same way. Astronomy is humbling in that regard. We start out thinking the Earth is flat. We started thinking the Earth, maybe it's round, but it's the center of everything. No, it turns out the sun's the center of everything. No, wait, the sun's not the center of everything. In fact, the sun is unremarkable. It's just another run-of-the-mill main sequence star. Who cares? But then the last thing for me, not just as a U.S. citizen, but as a citizen of the world, space exploration brings out the best in us. Space exploration challenges society in a way that nothing else does. And so when you have space exploration going on, it's inspirational. People think about the future. They think about the possibilities. People accept. They believe that the future is inherently better because they're doing new and exciting, cool things and learning about our planet and its place in the cosmos. Space exploration makes us better as a species. And so this is why this stuff is vital. And this is why we at the Planetary Society, if I may fight the good fight, for planetary science at the world's largest space agency. And
what can viewers of this show, what can we do? You know, if we want to, if we would like to go to more places in space, what kinds of things can we do if we're U.S. citizens and if we're not?
Well, if you're a U.S. citizen, vote for space exploration. If you're a U.S. citizen who's not able to vote or does vote, you should write or contact your representative and congressman, your senator. Say, hey, Mr. or Ms. Representative, Mr. or Ms. Senator, what's the deal? Like, let's support planetary space exploration, planetary science. Let's get out there and do it. Don't cut that aspect of the budget. And yes, people are going around and around, and it's very, if I may, wonkish. That is to say, you got to get into these details of legislation. But people do that, and the people who do that are here at the Planetary Society. The other thing you can do, of course, just to put a plug in, you can support the Planetary Society because we wonkishly pay attention to who represents whom and who's in what zip code and what district is represented by this and that. And we do contact these congressmen and senators and influence them. It is pretty clear that there would not be a mission on its way to Pluto without the Planetary Society. We're very hopeful that planetary science will be restored because of our work at the Planetary Society. So those are things you can do. And I know that you're feeding me questions.
Well,
I'm not kidding.
Yeah.
Supporting us and writing to your congressman are real things.
One of the things that I did for the very first time recently was actually in response to a different call, the problem being that, that the federal government for some reason can't seem to get the production of Plutonium-238 restarted so that we can have the power supplies that we need for outer planet missions. And so for the very first time, I actually called my senator's office. You don't get, put through to your senator, but you call a staffer, and the staffers do. It's their job to take down your concerns and add them to the list. And it's amazing. I've heard how few phone calls it takes to actually make your representative sit up and take notice. So if a couple of you can summon up the courage to actually call your representatives, you might actually help us get somewhere.
So along that line, my heavens, Plutonium-238 is not weapons-grade plutonium. It's this other stuff. And it is, you guys, this really is in the details. This is down in the weeds. But here's the thing. If the United States, which has the capability to make plutonium, it doesn't exist in nature anymore, at least not on Earth. If the United States stops making Plutonium-238, there just isn't a lot of it around. I mean, you can get it, people make it in Russia or in one of the former Soviet Union states controlled or funded by Moscow. But without the U.S. making Plutonium-238, you don't have this unique material that's suitable for powering spacecraft in deep space. It's the kind of thing, if I may, that great governments do. Great governments produce this exotic, albeit dangerous material, really for the betterment of all humankind. Every image that comes back from a spacecraft powered by plutonium battery, plutonium radiothermoelectric generator, that image is public domain. That image is for all of us. The Hubble telescope images belong to everyone in the world. The Cassini images of Saturn belong to everyone in the world. And this is a wonderful thing. This is another example of space exploration really doing what it can, bringing out the best in us, making us a better species. And I admit, plutonium is crazy dangerous. I had lunch once with Glenn Seaborg, who, unlike many of us, had a Nobel Prize. And he told me the story. He invented or created or made to come into existence the very first plutonium. And he insisted, he told me they wanted him to call it Plutonium. But he said, come on, Bill, plutonium, that sounds a lot cooler. I said, yeah, Glenn, yes, it does. He was in his 80s at this point. Anyway, they named element 106 after Glenn Seaborgium. But the other thing, he insisted that the atomic symbol for plutonium be Pu, because it stinks. He wanted to emphasize to everybody how dangerous the stuff is. It's the heaviest of heavy metals. You go inhaling plutonium and you're done for. So it's, albeit it's dangerous, but it's important. So way to go, Emily. Way to call your senator.
Can I mention that, this is Matt, by the way, Mat Kaplan of Planetary Radio for the Society, interrupting my boss. I'm just sort of the visible lurker here today. Did you ever build one of those kits, the visible woman and the visible engine and things like that? I thought I would point out, let's see if I can get this to work. Emily says it does. This is Juno, if you can see it. This is the mission that is currently on its way to Jupiter, not without RTGs, without plutonium. And they had to go to incredible lengths to make this work. They had to make a really efficient spacecraft, and they also had to build these hulking solar panels. And it's just not going to be as capable as it would have been if they'd had a nice, sure source of electricity, as we should point out Curiosity does, the rover on its way to Mars. And Jupiter's it. From what I'm told, Emily, is this the case? I mean, you really can't expect to get past Jupiter without RTGs.
No, and as a matter of fact, there is another spacecraft that's out there about as far as Juno's going to get, called Rosetta, and it went to space with some of the largest solar panels ever sent to space. And it is actually, it at its distance from the sun, it's generating so little power that they actually had to basically turn the spacecraft off for about 2 or 3 years and say, you know, bye-bye, hope we can turn you on again when it's time for you to come back around and visit a comet. So, I mean, they're pretty confident. The European Space Agency is very good at building spacecraft and operating them, but it's still extremely scary to have to shut off your spacecraft and not hear from it for a couple of years until its alarm clock tells it to wake up. And hope that you find it again when it's supposed to wake up. And that's what they have to do because the European Space Agency simply doesn't have plutonium-238 in order to be able to power their spacecraft. We have enough plutonium for one more small mission, and that's pretty much it. We have to restart its production soon. It's going to take several years to ramp up production in order to be able to power other spacecraft out to the outer solar system. I want to add that not only is plutonium-238 not weapons grade, but the process that produces plutonium-238 cannot produce weapons-grade plutonium. There is nothing relating to weapons associated with this stuff. All this stuff is a small mass that generates lots and lots of heat, and spacecraft get their power by turning that heat into electricity.
Maybe we could get an agreement with Iran that they would only produce plutonium-238 to sell to the rest of the world. I wanted to make sure, because I realized I hadn't actually shared my screen, but there is the Juno spacecraft, if you didn't see it before.
It really is a cool thing.
So, Bill, I have a question from the audience, and I should pause here to say that we are broadcasting here on the weekly Space Hangout. This is the Planetary Society. I'm Emily Lakdawalla. We've got Bill Nye and Mat Kaplan also here. And if you want to ask any questions of Bill or anybody else, you can either post them in the comments on the Google Plus Hangout page, or you can send them by Twitter using the hashtags #CQX, #Hangout. And send those questions in and we'll get them answered. I have a question. Oh, I'm also supposed to mention that I am doing this as a collaboration with Cosmoquest, which is really an umbrella organization for a lot of space outreach that's being performed right now, including a lot of citizen science projects. It's a place to get connected with lots of other people who are also interested in space research and exploration. So go to cosmoquest.org and check that out. So I have a question here from Brian Lefkowitz, who he wants to know, Bill, have you read Neil deGrasse Tyson's latest book, Space Chronicles?
I have not read it yet.
Has he
but
told?
I've spent a lot of time with Neil, and I know what he's driving at. And his premise is that people who expected everybody to go to Mars right after we went to the moon were not fully understanding the situation. Now, I don't want to put words in Dr. Tyson's mouth, but humans went to the moon because of the Cold War, because of a disagreement with another superpower. And by fabulous rhetoric, both countries got involved in trying to get to the moon first. So after one country did, and the Cold War was not resolved, but winding down, people were not motivated to go to these remote places anymore. And people lose sight of that. People forget it's the Cold War that brought us this remarkable legacy of space exploration. So it's not bad, but everybody should keep in mind that without that conflict, and I'm not a full-time historian, but without that conflict, which probably was derivative of World War II, which was derivative of World War I, which is derivative of ancient geopolitical disagreements in Europe or Eurasia, we wouldn't have this ability to go into space. And think of this. This is a new idea. Is it Mr. Lefkowitz? Is that his name? Brian? That it may be a very lucky thing that if you are a civilization on a planet orbiting a star, and you don't, for some reason, develop a space capability, a space program, you probably will have a much more difficult time deflecting an asteroid when that opportunity comes along. So this could be cosmic dumb luck, that we had a Cold War and a moon close enough to declare a goal, and we ended up with this ability to travel between planets. It's quite a thing to think about.
Something we've been talking about on the radio show, Planetary Radio. In fact, this week's show, here's a plug, at planetary.org/radio. It's a conversation with a fellow named Jaime Noman, who is with La Sagra Observatory in Spain, just like 3 weeks ago, they discovered a near-Earth object that is going to swing very close to our planet next February. And then we all got to watch, because you never know what's going to happen when you get that close to another gravity well. Who knows, on some other trip not too far down the line, it could swing right into us, and that would ruin some city's day if it happened to hit.
We're getting a couple of questions from the audience on relating to human exploration, the relative importance of human exploration versus scientific missions. And the questions are whether you support human exploration, whether you think it's a valuable use of our funds, and whether you think that it's a problem that we're constantly being forced to choose between the two.
Well, it's a problem, and say we, the National Aeronautics and Space Administration, is often forced to choose. Now keep in mind, I applied to be an astronaut several times, but after Christy McCullough got killed, my bid was not so viable. That aside, as John Grunsfeld says, the guy who's now the head of NASA science, he's flown in space several times. He was the guy who repaired the Hubble's telescope and had difficulty wearing a spacesuit. He didn't just show up. He says, we've gone to the easy places. We've gone to the moon and back. We've gone to low Earth orbit. Over 550 people have flown in low Earth orbit. Not 50, 550. But getting out beyond that is a very difficult thing. It's a difficult thing. And so everybody's got to agree that it's worth doing. Now, for me, I'd like to send humans to an asteroid and catch up with an asteroid. And you would say, well, what are you going to find there on an asteroid? We don't know. That's why we're going to go have a look. And that would prepare us to one day send people to Mars. And keep in mind, 550 people have flown in space. And if you said, can you name anybody on the International Space Station? Very, very few of us can. Very few of us. Out of 7 billion people, there might be 70 that can do so. But if there was somebody going to Mars, everybody would know his or her name. Everybody. If you had a mission to Mars, instead of nobody knowing who was on board the station, there'd be a line around the block. There'd be a line for kilometers of people signing up to fly to Mars. And this is part of the inspirational nature of human exploration. So yes, human exploration is vital, but I believe that it has to be based on a mission. We have to have a reason to go to someplace rather than just building large hardware to go for the sake of getting off the Earth's surface. Now, before we let go of that, if I may, we keep a presence in Antarctica. There are scientists in Antarctica, in the South Pole, working all the time, studying the ice, the atmosphere, the living things there, because they make discoveries continually. So in the same way, you keep people in low Earth orbit. You keep people on the International Space Station. They make discoveries all the time. But what we want is to go to someplace, to send people to someplace new and exciting, to make new discoveries, to find something new, to learn more about, especially for me, objects that could change our way of life in a catastrophic fashion, just getting hit with an asteroid or a comet.
Bill, you made me think of all those people out there, the crazy but admirable folks who signed up for a one-way trip to Mars. Yeah, I think you'd have a line around the block.
Yeah, now the one-way trip to Mars, you guys, it's easy for the pioneers to go from a culturally repressed Europe or Eurasia to California. I mean, I get that. The orange trees were like weeds after the Spanish got them planted and established. Okay, but Mars, there are no orange trees. There's nothing to drink. It's fantastically cold, and there's nothing to breathe. For example, how many of you would want to go live in Antarctica for a few years, just to see what it's like, just to be pioneers? Plenty of open space, and I don't mean the Antarctica with the ice and the penguins and stuff. I mean the dry valleys. It hasn't snowed in over a century. and there is nothing to drink, nothing for humans to eat, and there is something to breathe. How many of you want to try that? Mars is an extraordinarily difficult place to make a living. I'm not saying it can't be done. It's just, it ain't so easy. It isn't changing channels, watching various sci-fi shows.
I was actually today visiting a small business that develops space technology, Honeybee Robotics, here in Pasadena, and they were showing some examples of the stuff that they had worked on in Antarctica, actually doing field tests. And they said the field tests were great, but we were miserable. And you saw a video of them, and they were like shaking and beating their hands against their legs to get the circulation back into their fingertips. Antarctica is hard. So let's move on to the next question. We've got one from Faisal Saeed Al-Mutar from Iraq. He says, how do we advance our understanding of cosmology in our country where people believe in delusions? And I think that we can broaden this question more generally, Bill, to ask, how do you deal with people who may not use science as a screen through which to view the world?
Can I just say, we have plenty of those delusional folks over here too, brother.
Indeed.
Yeah, I'll tell you, you're not alone. We have, in the United States and the United Kingdom, for example, in Africa, these are places I visited, and especially in China, there are an enormous number of, for lack of a better word, superstitious people. Believe in forces that science can't document and so on. So what I always encourage is try to ask them why they don't believe in the scientific explanations. What is the real reason you don't, in the United States, our problem is you don't believe in evolution. What is the real reason you think the Earth is only 6,000 years old? And you'll find that they start to challenge themselves. And I guess what I'd say, it's a process. You're not going to influence people in one sitting. But we chip away at it, and I always encourage people to be open-minded. But of course, when you're confronted with angry people, in the United States we have a joke, the pitchforks and torches. These would be people from a very popular, frightening novel called Frankenstein, Dr. Frankenstein. You just got to chip away at it. When they're angry with you, you just try to listen. And you're not going to influence everybody in one Google Plus hangout. But the longest journey starts with a single step. And this is, as you may know, my mission. I chip away at this problem every day. So hang in there on this hangout.
Let's see here. Oh, we have an interesting question here from William McCloskey. He wants to know, would you take a commercial ticket into orbit to help bring attention to the issues of human exploration in space?
If I thought that would bring attention to human exploration in space, my understanding right now it's $200,000 for 3 minutes of what's called black sky and about 1.5 minutes of zero G.
I think he means they were going to comp you.
Oh, cool. Oh, if I'm comped, party on. Yeah, bring it on. If I get to go for free. I'm pretty good, even at my age. I'm pretty good with G's, G forces and flying and motion. I'm pretty good with that. Yes, bring it on. I think, shooting from the hip, I'd like to wear a cool flight suit. Like a cool flight suit.
I think that comes with the price of the ticket.
But this business is coming up, it's an extraordinary amount of money, but they have over 450 people who have signed up for this ride. So I say more power to them.
We got to get out there.
I remember many years ago when I was very young, I met Buckminster Fuller, who's the guy who popularized the geodesic dome. It's a very efficient structure from a material standpoint. That is to say, you don't have much material, metal or carbon fiber or plexiglass or what have you, to make a very large volume building. He did calculations showing you could make a geodesic dome that would float on the atmosphere. How cool would that be? Oh man, it's an investment though.
Someday
It's a
soon.
large investment.
Let's say keep an eye on the website, because George Whitesides, our friend at Virgin Galactic, he runs the place, has invited us out to the Mojave to take a look at Spaceship Two. So we'll be dragging a video camera out there before too long, I certainly hope.
And by the website, of course, Matt means Planetaryorg, where you can find all kinds of great updates, including my blog, which I write every day to talk about cool space research and exploration. And Bill, I'm wondering if you can tell me what some of the most exciting, what you think are some of the most exciting discoveries that have been made recently in space.
Well, water on Mercury took me off guard. Ice on Mercury. And then, well, just for me, when you see animations from still pictures of dust devils on Mars, that gets me. I gotta say, that gets me. The icy cracks on Enceladus, they're just crazy. They're just beautiful. These are places that are so extraordinarily remote, yet we have a lot in common. I guess you know what, Emily? The most remarkable thing of the last few months, I think for sure, was the number of planets that seem to have the right temperature for liquid water. I remember very well being in Carl Sagan's astronomy class, and he speculated. He said, it seems like all the stars should have planets, but we have no evidence of that. It may turn out that our planetary system, our solar system, is unique, or in a very small fraction of the stars that are extant. But it turns out that probably every star has got planets, and then an extraordinary number of stars have planets that are not that different from ours. That, to me, that's probably the most remarkable thing.
I think Kepler's discoveries have really taken us all off guard, where there's so many different kinds of worlds that we can imagine than we've ever even thought about existing before. All these hot Jupiters and these water worlds and these things in crazy different kinds of orbits, and sometimes even free-floating planets. I even read a paper recently that said that that there could if life had originated on a planet that orbited a sun, and for some reason the planet got ejected from the solar system, that you might actually, life could reasonably survive inside such a planet if it was like Titan-sized and had like an internal ocean. And so I think that all of this, it seems like it should be seeding science fiction. I'm wondering what role you think science fiction plays in helping us imagine the future of space exploration.
Are you asking me?
I am asking you.
That's the greatest thing ever. And for those of you of a certain age, such as I might be, you might recall the original Star Trek episode where the world is hollow and I have touched the sky. Yeah. Anyway, these are old science fiction ideas that are based on science. So there's shows on Science Channel now where people travel from one side of the galaxy to the other, and they do that through wormholes. And wormholes are extraordinary ideas that may or may not be a consequence of the mathematics of physics, the mathematics of the universe. What you find in the universe is so extraordinary it cannot help but stimulate science fiction. So it can help to stimulate your imagination. It's just so, all this stuff is so crazy that for us, we always have to look at it from our point of view. We've always got to put humans in the scene. But that turns out to be, probably in the universe, a hard thing to really put humans everywhere. But if you stop thinking about it, I say, just stop doing anything. I mean, that's so inspiring to imagine other worlds and other living things. Come on, it's the coolest thing ever.
We have a question from Twitter. Graham2128 wants to know, when do you think we will get a human to land on another planet, or maybe the asteroid, or even back on the moon? Do you think we're going to see that soon, or what?
Back on the moon, I'm pretty sure you will see Chinese Space Agency pull that off in the next 20 years. Now, I would say the next 5 years. But what happens, we all think the future is closer than it is. And we all think it's going to be, the changes are going to be worse than they turn out to be, and so on. But the Chinese Space Agency will certainly have people there in 20 years, but maybe in less than 10. And then when that happens, everybody in other space agencies will get all a flutter. Meantime, you know, we've got asteroids that have our name on it. And so I would like to get asteroids. I'd like to get astronauts out to asteroids, let's say, by the year 2030. I'd like to do it this next weekend, but that's it's a very difficult thing. So let's say if I were king of the forest, and I'm not, by 2025, but let's say realistically by 2030, 2035. We'll see. It takes us, the space interest community, nudging our leaders to remind them of the great value of space exploration. That's how we're going to make it happen. It's up to you and me to, dare I say it, change the world.
I think there's the mini space race that's on the other side of the planet right now between China and India. And China has a pretty good head start. But there is no question that India is going through the same kind of Sputnik moment that we did many years ago. And yeah, I wish them both the best of luck, because I think you're right. I think that would be the primary driver of a lot of other space programs, including the United States space program, starting to be much more daring as it once was.
I want to pause here and just for a station identification again. This is the Cosmoquest Weekly Science Hangout with me, Emily Lakdawalla, Bill Nye, the planetary guy, and Mat Kaplan of the Planetary Society. Those of you who are watching on Google+, please +1 this broadcast so we can tell how many people are watching it right now. And you can ask questions by posting comments on the Google Plus broadcast or by tweeting any questions with the hashtags #CQX, #Hangout. And the latest question that we've received is, Bill, what place in the solar system, this is from J. Graff, Jay asks, what entity in the solar system other than Earth do you think has the best chance to be harboring life right now?
Harboring life right now, I'd say Mars. I still go for Mars. And people say the surface of Mars is cooked by extraordinary radiation all day, but there are glaciers below the sand on Mars. So I want to go to a deep rift, someplace where we get access to, like a geologist go to valleys to look for layers of rocks. We get access to the edge of a subterranean glacier, a glacier under the sand. And then it's near hypothetically, it's near the equator, and the sun warms the ridge or the valley wall, and this super salty water is oozing out, and there is some crazy Mars organism that is able to thrive on super salty water in extraordinarily cold area where the surface is irradiated with intense cosmic rays and ultraviolet. The next place I think, and Emily, you probably know more about this than I do, my goodness. The next place I think is Enceladus, or is the next place Europa?
I just said Europa. I was going to ask you, how far behind Mars would you put, either of you, put Europa?
In what, a scale of 1 to 10 or something?
Yeah, if Mars is a 10.
I'd say it's half as likely.
There's on Mars with the Phoenix mission that landed in 2008. That one really opened my eyes. They scooped down below the surface and reached the ice that was sitting just a couple centimeters below the surface. And one of the scientific conclusions that they came to after they analyzed their data was that there is actually liquid water in this icy northern waste right now. There are these tiny little thin films, just a few molecules thick, sticking to dust grains sitting near the surface of Mars, and it's just a few molecules, but it's enough for chemistry to be happening. It probably is not a good place to imagine any bacteria thriving, but still, you know, if even in this really awful, inhospitable place, near the North Pole of Mars, you can have liquid water with chemistry happening. It does seem that life is more possible on Mars than I had thought before. The other thing, Bill, that I thought that you might want to talk about is the whole the panspermia hypothesis and what that means for life in the solar system.
Well, everybody, look, if we found living things on Mars, the next question would be, and I'm talking about microbes, right? The next question would be, well, what are they like? Do they have cells? Do they have, dare I say it, DNA, deoxyribonucleic acid? Is it like ours? And get this, everybody, suppose it is like ours. Suppose that Bill's slushy outcropping, Emily's biofilm layer of water, thin, crazy film of a few molecules, there's something alive that is very much like the cells on Earth. Well then, my friends, it is not beyonding to imagine that when Mars got hit by something 3 billion years ago, and these pieces of Mars were tossed off into space, and some of them landed on the Earth, and we know this because we pick up Martian rocks from time to time that have amino acids in some meteorites. It is possible that life started on Mars when the sun was of a different configuration, Mars farther out, cooled off faster, this and that, and that we are all descendants of Martians, Martian microbes. That is extraordinary, but not crazy. And so this is worth investigating. This is worth knowing. And I remind everybody, if you are a citizen of the Earth who pays taxes, it's less than 1 cup of coffee to run a mission to Mars. Not 1 cup of coffee every week, no, 1 cup of coffee per taxpayer. And we can send a mission to Mars. That is an extraordinary thing, because this discovery would change the world, and wait, there's more. The discovery is not made by an individual. It's made by a team of people supported by a society who felt it was important to invest their intellect and treasure in this extraordinary exploration. It really is a wonderful thing, and that's being curtailed right now in the United States, perhaps by accident, perhaps by mean-spiritedness, perhaps by lack of pay-attentivity to the value of planetary science. This is heartbreaking, and this we're working to redirect here at the Planetary Society. This is a great question, Emily. It's great. It's deep. It's wonderful.
Emily, there you go.
Yeah. So we have a question from somebody who's watching whose name is William. He's a 13-year-old student, and he says he's been a fan for a really long time. He says, what do we need to accomplish if we take shuttle missions to Mars, Jupiter, and other heavenly bodies? If I understand his question correctly, I think what he's asking is, what do we need to do in order to be able to send people to these other places? And
well,
William, I'm sorry if I mangled your question. If you want to clarify, please go ahead and try to ask.
I know what you mean. The shuttle itself, just as a detail, the shuttles all got old and a little bit rickety. There were a lot of, a shuttle flight cost $1 billion. That's a lot of money for one flight. Anyway, that aside, to send some sort of spacecraft to these other worlds would be a fantastic thing. So what's involved is figuring out how we would arrange the flights, the orbits, the rendezvous points. There's a whole school of thought. People believe you should build a huge rocket and just go to Mars with people and somehow protect the people from the radiation in deep space, protect them from the effects of weightlessness. Since the 1960s, human bodies have been shown to not do so well in weightlessness. And the other thing, really, this is not an unreal thing. We've got to figure out how to keep people from going crazy, or just driving each other nuts, staying in this one small spacecraft for years, going back and forth. Then there's another school of thought that says what we need to do is put fuel depots. These would be tanker trucks full of rocket gas out in space, so that you would go up and refuel up there and then keep going. You do it in stages, in pieces, in segments. And rocket scientists love to sit around and talk about this. But what's really needed, William, is the belief that it's worth doing. What's really needed is the commitment that this will bring out the best in humankind. We will make discoveries that we can't predict. We will change the world. This has to be something people believe in. And bear in mind that if you're a government official, you've got a lot of other stuff you got to take care of. People need health. All the humans on Earth still seem to thrive on conducting wars, and so we need departments of war and defense. We need the streets to be paved, the stoplights to work. We need the sewer systems to work, the telephones to work, the internet to be protected. We need all this stuff to keep working, and space is just one more thing to invest in. But our claim at the Planetary Society and at other space interest organizations is that investment in space really comes back to improve the quality of life for everyone. So this is a great question. What do we need to send people to other remote places in the solar system? And I would say what we need is a belief that it's worth doing, a commitment that it's worth doing. That's a great question.
Can I make a suggestion to William? William, if you are anywhere near Washington, D.C., and you want to go to the coolest science event ever, here it is. It's the United States of America Science and Engineering Festival. And there may be 500,000 people there, and they'll all be asking questions like yours and having a great time. Planetary Society will be there with a large booth, and Bill will be there. We're doing a major presentation, but lots of other really cool stuff that will be going on in that last weekend in April.
And Cosmoquest will also be there. They'll have a booth in the NASA area. So
oh, great.
It's going to be a big space party.
I've got a question for Bill as we get near the end here. Is this the first public showing of the new Planetary Society logo behind your head?
I guess so, yes. Yes, it is. Yes. Now, this is probably not the final. There may be some detail about the spacing of the letters, but this is basically what we're working on. So I'll keep it in the background and tease you all. The new Planetary Society logo has motion, is forward-thinking, is part of the future, is exciting, and is, when people look at it, and Matt corrected me if I'm wrong, it makes you feel like you're moving. It makes you feel like you're going somewhere.
About warp 7.
We're excited about that.
So we've got a couple more questions from the audience here. We've got one from Saravia. I'm not sure if I'm pronouncing your name correctly. The question was, Bill, do you believe in the possibility of the existence of other intelligent life elsewhere in the universe?
Yes. I've never heard a strong argument for why there wouldn't be. The scale of the thing is so remarkable. This is to say, there are 200 billion suns in our galaxy, and there are 2.5 times that many galaxies. So the chances of there not being intelligent life just seem so remote. I mean, there's got to be intelligent life. The thing is, have they come to visit us? Almost certainly not. But I do leave in the almost. No, we've never been visited by aliens. No, not happening. But they're got to be out there. Got to be.
So here's a question from Michaela Knott. She asks, what was your favorite NASA mission after moon landings and why?
Oh, well, so far, it's the Spirit and Opportunity rovers, if I can call that one mission. So far. I mean, I love them all. Don't get me wrong. Who doesn't love Messenger? Who doesn't love Cassini? Who doesn't love Juno? I went down for the second to last space shuttle launch. That was cool. It was great. Fantastic. But the thing that really has my heart are the Spirit and Opportunity rovers, because I was involved in that mission, albeit in a tiny way. And then I referred to the crazy sundials that are up there on Mars. And by the way, we're going to rev up the Earth Dial project again, where we try to get people around the world to build a sundial that's visually reminiscent of the sundials that are on Mars. So there's 2 of them up there, sundials on Mars. There's 2 of them up there right now. And the third one, which was sitting in Jim Bell's desk drawer for several years, is been cleaned up and it's screwed down, and it's on the way to Mars right now. While you and I are sitting here, there's another sundial in deep space ready to cast a shadow on another world. And I found these things inspirational. It's a personal thing, I mean, I admit. But those, if you have to pick one mission or one overall mission, and I mean, I love Spirit. It's stuck in the sand, so right now I'm rooting for Opportunity. But it's the same deal. It's rovers on another world, powered by the sun, with sundials inspired by my father's hardships in World War II. And it's just something I lived through and is part of me.
So, Bill, I think it's time for our very last question, and it's kind of a funny one. It's from Teal Britstra, and she wants to know, when is it going to get renamed the Interplanetary Society?
Well, bear in mind, first of all, there is the British Interplanetary Society. And in 1935, when the BIS was formed, interplanetary was the word they used before they really had the word astronautic. You know, I'm a member of the Astronautical Federation and so on. But people say all the time, what's your favorite planet? People may have asked you that. What's your favorite planet? And quite often, if you have school kids who are about 12 years old, 15 years old, school kids will say, Pluto! Pluto's my favorite planet. When you get down to kids who are 6, they'll say Saturn. But for me, and I think for all of us, just to give you something to think about, my favorite planet is the Earth. This is where I was born. This is where all my friends are. If it's the Earth versus Saturn or Pluto in the solar system cup, I'm all about the Earth. So for us at the Planetary Society, yes, we want to compare our world to others, or we want to compare worlds, Venus to Mars. We want to understand Saturn. We want to understand the moons of Jupiter that are so Earth-like in dimension and aspect. But the most important planet for us humans is the Earth. So understanding the Earth in planetary terms, or with a planetary perspective, is very important. So while I'm CEO of the Planetary Society, we're not going to change the name. Boy, that is a great question. That is a great question. Thank you very much. Thank you, everybody. This has been just great. Thank you all for participating.
Yeah, thanks to the whole audience for watching. Those of you watching on Google+, please +1 this now so that we know how many people are watching. Thank you all for participating. If you would like to do this again, there will be the next Cosmoquest Hangout is tomorrow morning at 10 a.m. I'll be on there again. 10 a.m. Pacific time. You'll have to convert that into other time zones, remembering especially that this is that weird 2 weeks when the United States has switched to summertime and the rest of the world has not. That one is hosted by Fraser Kane and has on it a number of other space bloggers. You can follow my blog at planetary.org/blog. You can listen to our podcast at planetary.org/radio. Bill and I are on that with Matt every week talking to different space experts about what's going on currently in space research and exploration. Next week, I and actually most of the rest of the cast of the Thursday morning Hangouts are going to be at the Lunar and Planetary Science Conference in Houston, which is a huge gathering of planetary geologists talking about the latest research in space science exploration. So tune in to my blog and to Cosmoquest for the latest updates on that. Again, it's planetary.org/blog or cosmoquest.org. So thanks for watching, everyone. Thank you very much, Bill and Matt, for participating. Everyone, please +1, and I hope you'll tune in next time.
Take care. Bye-bye.